Now that we have learned all three panel data models, namely fixed effects, random effects, and pool OLS, in topic 6, we will learn the procedure to determine which of the three models is the best model or the preferred estimator. Before we proceed further, let's recall the model's key assumption. Fixed effect model assumes the unobserved heterogeneity factor is present and correlated with the regressors, whereas random effect model assumes it as present only and not correlated with the regressors. On the other hand, pool OLS completely ignores the unobserved heterogeneity factor across the countries and assumes that it is not present. Hence, in the model selection procedure, we must ask these important questions about our panel data. Firstly, do we really think that the cross-sectional units in our data, like countries in our sample data just now, are identical and have no unique characteristics? If our data are about firms or persons, then do we really think that the firms or the persons are identical? In other words, if we think the unobserved heterogeneity factor is not present, then we can simply run OLS on our panel data. However, we must remember that this is quite a strong assumption because panel data often have this country specific or firm specific or individual specific factor that may cause heterogeneity bias in our estimation if this factor is ignored. Next, if we agree that the unobserved heterogeneity factor exists, we need to ask whether it is correlated with the regressors or not. If it is correlated, then we have to use the fixed effects estimation. Otherwise, just use random effects estimation. So there are two tests in the model selection procedure, namely Hausman test and Breusch-Pagan LM test or BPLM test. These are the commands to run Hausman test. The word quietly here means that you don't want Stata to display the estimation results of this xtrec command, but the result is still available in the Stata memory. Estimate store is to ask Stata to save the results in the memory by the name FE here. So we repeat the command for the random effect estimation and save the result as RE. And finally, we write Hausman FE RE. Remember, the sequence must be like this. We start with fixed effect estimation, save the results, then random effect estimation, again save the result for the random effect, and the Hausman test command. Here is the result of the Hausman test for our sample data. We can see here, Hausman test is meant for testing if there is any systematic difference between fixed effects and random effect estimation. We know that this systematic difference is the outcome of the correlation between an observed heterogeneity factor in the error term and the regressors. Here we get p-value greater than 0.05 significant level. Therefore, we cannot reject the null hypothesis, which means there is no difference between the two estimations, or the difference between the two estimations is not systematic. To interpret this finding, we can say that the unobserved factor is simply exists at random and not correlated with the regressors. Therefore, random effects is preferred when the result of Hausman test is not significant. Suppose that we get p-value smaller than 0.05 and the result of Hausman test is significant. Therefore, we can reject this null hypothesis. It means that there is a systematic difference between the two estimations, between fixed effect and random effect. Therefore, fixed effect is the preferred estimator. So when we get significance Hausman test result here, and the fixed effect is the preferred estimator, we often no longer need to run BPLM test anymore. But here we have the Hausman test not significant and the random effect is preferred. So we need to further test for the unobserved heterogeneity factor. We have to run the BPLM or Breusch-Pagan LM test, which is meant for choosing between random effect and pole OLS. So this is the command quietly xdirect yx1 comma re. So we tell Stata to run the random effect estimation, and to the command is xdtest0 to run the BPLM test. We know that random effect model assumes the unobserved heterogeneity factor exists at random, but pool OLS model assumes it is not present whatsoever. The null hypothesis of BPLM test here says that the variance of the error term is zero, which means that the unobserved factor does not exist. Here we get the p-value greater than 0.05 significance level. Therefore, we cannot reject the null hypothesis, which means that the unobserved factor in fact does not exist. Hence, pool OLS is the preferred estimator. Suppose that we get p-value smaller than 0.05, so the result is significant, and we can reject the null hypothesis. It means that the random effects model is preferred. That will be all about the model selection procedure.